Today's lesson will be on similar polygons. This is section 7-3 in your textbook. The essential question for this topic is, what are the properties of similar figures? In previous lessons, we learned about congruent figures. These are figures that have the same size and shape. So if that's true, what do we mean by similar figures? In general, we might think of similar figures as having the same shape but different sizes. So let's see what we can come up with for a specific definition for similar polygons. So our formal definition might look like this. Polygons are similar if their vertices can be paired so that 1, corresponding angles are congruent, and 2, corresponding sides are in proportion. That is, their lengths have the same ratio. So look at what we've got here. We've got two similar polygons, or at least we are assuming they're similar polygons. Now, look at the corresponding angles. We have a larger polygon, a four-sided figure, a quadrilateral, ABCD, and we have a smaller one, MNOP. Now, if we look at the corresponding angles, for example, A corresponds to M, and those angles appear to be congruent. B corresponds to N, and again, those angles appear to be congruent. C corresponds to O, and those angles would appear to be congruent. And lastly, D corresponds to P, and those angles appear to be congruent. So we definitely meet the criteria of the first step above. Now, are corresponding sides in proportion? In other words, do their lengths have the same ratio? Well, look first at BC. BC is 3 inches. Now, the corresponding side to BC is NO. That's 2 inches. The ratio of the larger to the smaller is 3:2. Now, look at CD. That's 6 inches. That corresponds to OP, which is 4 inches. The ratio of those is 6:4, which can be reduced to being 3:2. Similarly, DA corresponds to PM, and those are also 6 and 4. So the ratio there is also 3:2. And then lastly, the last side is AB and MN. Well, AB is 9 inches, MN is 6 inches. The ratio there is 9:6, which can be simplified as 3:2. So yes, the corresponding angles appear to be congruent, and the corresponding sides are in proportion. That is, their lengths have the same ratio. So this is how we determine whether we've got two polygons that are similar. Now, how do we once we know they're similar, how do we identify them? Okay, so we would write this as ABCD is similar to MNOP. Now, there's a couple things to notice. First of all, what is the symbol for similarity? That's that little squiggly line. It's not an equals, it's not two squiggly lines, it's just one squiggly line there. And that means that we're talking similarity. Okay? Now, next thing is, notice the order of the letters. On the left, I identify that polygon as A, B, C, D. So therefore, the right polygon has to be identified with the corresponding vertices in the proper order. So what corresponds to A? That's M. What corresponds to B? That's N. C corresponds to O, and D corresponds to P. So they must be in that order. If instead I had said, now if I had identified the left polygon as DCBA, I could not identify the right polygon as MNOP. I would have to identify the right polygon as PONM in this case. So the order that you have the letters makes a difference, okay? So depending on how you order the letters initially determines how you're going to order the letters for the similar figure. Now let's go back to the corresponding sides and the ratio. As we were saying, that the ratio of the corresponding sides is 2 to 3. So this ratio of corresponding sides can also be referred to as the scale factor. So in this particular case, the scale factor is 3 to 2, or if you prefer decimals, you could say the scale factor is 1.5. Well, let's look at one last thing here, and that is, again, the corresponding sides are in proportion. They're in a ratio of 3 to 2. So what do you suppose the ratio of the perimeters of these two figures is? Well, if we look on the left, the perimeter of the larger figure is 6 plus 3 plus 9 plus 6. Okay, so that is 24. The perimeter of the polygon on the right is 4 plus 4 plus 2 plus 6, or 16. So the ratio of our perimeters, so therefore if we have a perimeter of 24 on the left and 16 on the right, the ratio of the perimeters is 24 to 16, or 3 to 2. So the ratio of the perimeters is also equal to the scale factor, just like the ratio of the individual sides is equal to the scale factor. So now, let's look at two similar figures. When we ever have two similar figures, we must refer to the corresponding vertices in the same order. For example, if we are talking about the left figure as polygon DCBA, we must refer to the right figure as polygon PONM. Okay? We must refer to them in the same order. So if we write the similarity function, the similarity statement, we would say that polygon DCBA is similar, and notice the similarity figure there is that little squiggly line, is similar to PONM. We must have the corresponding vertices matching up to be in the same order.